Unit 2, Day 5 notes. Today we'll be discussing geometry proofs. When we're discussing geometry proofs, we're going to use some of the similar properties from the algebra proofs. We're going to use the reflexive property again, which is also known as the reflection property. What is on the left of the equal sign should be identical to what is on the right, and that's the reflexive property. We'll also use the symmetric property. Again, that's also known as the switch property. If AB equals CD, then you can flip it around and say CD is equal to AB. We also have the transitive property. Again, if DE is 2 and 2 is equal to YZ, you can cut out the middleman, the 2, since it's the same, and simply just focus on putting the two ends together. So that's the transitive property. We'll also use the addition, subtraction, multiplication, and division properties of equality. It's just, you're going to see it look a lot differently than what we had with the algebra, because we're going to be using it for angles and segment pieces and other things to come in the future. Substitution as well, and distributive property could possibly show up, but not likely when it comes to the geometry proofs. On the pink sheet that we gave you, the properties towards the bottom, you'll find these listed. But there are a couple that I would like to highlight today because we might need them. We need to know the definition of congruent segments, and that is simply meaning that if segments are congruent, then they have equal measures. So again, if they're congruent, that means the measures equal. You need to know about congruent angles. Again, if their angles are congruent, that means their measures equal. If you need to know how a midpoint behaves, and the definition of a midpoint is, for example, let's say I have a segment ABC where B is the midpoint. So if B is the midpoint, AB is congruent to BC, which means that their measurements are equal. So AB equals BC. So that's the definition of a midpoint. Segment addition postulate was part plus part equals whole. So if I use my segment ABC that I just drew, I would say AB plus BC equals AC. And we talked about this earlier this year. The angle addition postulate, it's still part plus part equals whole, but from an angles perspective. So example, let's say I have angle ABC, and I draw another line and put point D on it. I would say the measure of ABD plus the measure of DBC will equal the measure of ABC. So it's the two smaller angles, ABD and DBC, together make up the larger angle, ABC. So that's the angle addition postulate. We have the definition of perpendicular already written for us, as well as some of the others. And we'll use those today. So here's our first proof. Again, it gives us the statements. We have to state the reasons. Given Q is the midpoint of PR, and if you look at statement 1, that's the very first sentence. So again, no matter what the scenario, statement 1 is always given. Then it tells us that PQ is equal to RQR. So if I come to the picture, I probably want to put a tally on both those pieces because they're equal. Well, we just discussed that if Q is the midpoint, then yes, those two pieces are going to be equal because that's the definition of a midpoint. Again, the definition of a midpoint is it causes the segment to break into equal parts. Statement 3 says R is the midpoint of QS. I saw that information before as well. If you look back at the given, that was also part of the given. So we have another given statement. So now R is the midpoint of QS, and I'll highlight that for you. Yoinks, go back. Sorry, I accidentally hit the wrong thing on my screen. So here's QS, and it says that R is the midpoint, so that means RS and QR are going to be congruent. So that's the, again, definition of a midpoint. Statement 5, if you read it, it says PQ plus QR equals QR plus RS. The only difference between statement 4 and statement 5 is the fact that you see QR on both sides of the equation in addition to the PQ and the RS. So they essentially added the same thing to both sides, and since they added the same thing to both sides, that was the addition property of equality. And then when you look at statement 5, since QR is repeating itself, you can essentially cancel it out and simply merge the two ends of the equation together, PQ and RS. So when you cut out the middleman that repeats, you're using the transitive property. Now, statement 7 says PQ, and I'll highlight that real quickly. PQ plus QR equals PR. So that is an example of part plus part equals whole. So that's your segment addition postulate. And it's another segment addition postulate when they talk about QR and RS together make QS. And the last thing that happens is simply the substitution property. I'm sorry, not substitution, subtraction property, because they are subtracting QR. No, I'm sorry. they're taking, oh my goodness. Hold on one second. All right, I'm sorry. The statement 8, in order to understand it, you have to go back and see what happened in statement 5. In statement 5, we had PQ plus QR. And in statement 7, we said that PQ plus PR is the same thing as PR. Also, in statement 5, we said that QR plus RS, and then in statement 7, we said that that was equal to QS. So we essentially substituted those simpler segments, the PR and the QS, in place of the more complicated segment pieces. And so we use the substitution method. Because we basically took the equation in statement 5, and instead of PQQR, we replaced it with PR. Instead of QR and RS, we replaced it with QS in yellow. So that's why we say we use the substitution method. All right, this next example, we have to deal with angles. So it's slightly different than the previous one, but some of the properties will be used are the same. Just it's going to look and appear differently. So the first statement again is you're given. It tells us that BE is perpendicular to CM. What that means is when two lines are perpendicular, they form a 90-degree angle at the intersection. So that is a 90-degree angle as well as this angle here. So now it says angle CME, if I were to highlight that for you. CME is this angle here, is a right angle. And again, we know that already simply because that's the definition of perpendicular lines. Statement 3 says the measure of angle CME will be 90 degrees. Well, that's the definition of a right angle. Then it tells us that the measure of angle CME will equal the measure of EMD, which is, I'll highlight that one for you. EMD is this one here, plus angle 2, which is here. And so essentially you have those two smaller angles making up the larger angle CME, so that's angle addition postulate. Statement 5 says angle 1 is congruent to angle EMD. So let me highlight angle 1. It's this angle here. So the yellow angle and the purple angle are congruent. You should recognize why they're congruent because we talked about it in Unit 1. Those are kissing angles, aka vertical angles, sharing the vertex and forming a perfect X. So again, it's because vertical angles are congruent. Statement 6 says the measure of angle 1 is going to equal the measure of angle EMD, and that's because that's the definition of congruent. The measure is equal. So now it says angle CME is equal to angle 1 and the measure of angle 1 and the measure of angle 2. If you notice back in statement 4, originally we had EMD and 2. Now we're saying in statement 7 that we have 1 and 2. Well, that's because EMD and 1 have the same measure, so we replaced EMD with angle 1. Since they have the same measurement, we replaced it. Since we replaced it, that's the substitution method or property. Also, if you compare step 7 to step 8, the only difference is the measure of angle CME disappeared and it's now replaced with 90. So since I replaced CME with 90, again, that is substitution. And then it says in step 9 that angle 1 and angle 2 are complementary. Well, it's because the measures equal 90, and that's the definition of complementary angles. So a lot of good stuff in that one problem. We have one more example. All right. It says the measure of angle 1 and the measure of angle 2 is 90 degrees. So that's given information. Then it tells us that angle 1 is congruent to angle H and K. So let's highlight both of those so you can see it clearly. Here's angle 1. And then H and K is right here. Again, we kind of just talked about those. Why are those congruent? Because they're vertical. Exactly. Sharing a vertex. So since they're vertical, yes, their measures are going to equal because that's the definition of congruent. Then it tells us that H and K plus the measure of angle 2 will equal 90. And that is because if you look back at statement 1, there used to be an angle 1 there. But now that we know that H and K and 1 have the same measurement, it's okay to replace it in that statement. So since I replaced it in statement 1, I can write statement 4. So that means I use the substitution method or property. Now it's telling us that the measure of G and K, so let's highlight that angle, is equal to H and K and angle 2. So G and K, the purple angle, is much larger than H and K and 2, so that's the angle addition postulate because it took the two combined to form G and K. And now, in order to answer the reason for statement 6, you have to go back and look at statement 4 and 5 together. In statement 4, we know that H and K and 2 make 90. So I can replace the right side with 90 since they are the same. So since I'm replacing, again, I'm using substitution. And then the last statement says angle G and K is a right angle, and that's the definition of a right angle. I do apologize for the length of this notes, but it's a lot of explanations that with practice, it'll get better, I promise. However, this concludes your notes for the day.